Hello guys, in this video we want to demonstrate how to resolve games problem, um, mixed strategy games. So of course in resolving the mixed strategy game, we'll first of all check if saddle points exist, and once we confirm that there is no saddle points in this, as we have it in pure strategy games, we'll now get into the finding solution to the problem proper. So for this, the company A, the player A, as we call it, the player A here, is seen as the minimizing player. So he sees this payoff as cost payoff. So he would go for any payoff that is, the least. And player A, which is the company A as we have it here, is the maximizing player. So he sees the payoffs here as profit payoff. So he would go for the ones that will maximize his profits. So what we do is the two players in a game situation are trying to not to be upset by the other player. So they are trying to protect themselves. So what they do is to first of all shield themselves from what the other player, from the activities or the actions of the other player. So having said that, a player B is the minimizing player and player A is the maximizing player. So what the player A will do to protect himself from the course of action that will be taken by B will be to, having known that he's a maximizing player, will be to go for all those, big values here, from which he will now select the list so that he will be protected. And player A, will go for small values, and after which he will select the maximum value from all the small values, all the small payoffs, in order to be protected. So first of all, check for the row minimum, so that whatever player B does will not affect A again. So for player A, he has three strategies. So we have A2, A1, A2, and A3. So in strategy A1, which one is the smallest payoff? I have 2. In A2, I have -1. In A3, I have +1, which is 1. So because A is a business to also make money, and having selected the least value, there is no other thing that player B that will do that will upset player A. So he will now select the highest of the minimum values. So the maximum of the minimum values, which is the mean. Then for player B, he will go for the column maximum first. Column maximum. So player B has 3 players, B1, B2, and B3. So in B1, the highest is 6. In B2, the highest is 5. And B3, the highest is 9. Because he's a minimizing player, he will go for the smallest value here, which is 5. This is now the minimum of the maximum values. So having seen that the row minimum or the maximum is not equal to the minimax, then there is no saddle point. There is no saddle point. And because there is no saddle point, the actions that will be favorable to the both parties will be now to find a way to mix the strategies available to them, and from there we now determine the optimal courses of action. So the first thing we're going to do here is to check if we have superiority in the strategies available to them. For instance, because player B is a minimizing player, if you have situation where all the payoffs in strategy B1 are smaller than the payoffs in strategy B2 or B3, we say that the strategy that has the smaller values for B is dominating others because it's now superior since it's a minimizing player. And for player A, if you have situation where all the payoffs, all the values in A1, for instance, are higher than the values in A2 all through, or you have a tie, and other ones are higher, we now say that player A1 is dominating A2. So we check for the superiority through a method called the rule of dominance. So we're going to see whether we can use dominance rule to see how to reduce this to 2 by 2 game, zero sum 2 by 2 game. So let's check using the rule of dominance. Now for player A, I can see is 2 higher than -1? The answer is yes. 5 greater than 2? The answer is yes. 7 greater than 4? The answer is yes. So we can see that player A1, that strategy A1 is dominating strategy A2. We're also permitted to jump strategies in our comparison. So let's check strategy A2 greater than 6? No. 5 greater than 1? Yes. So no dominance here. 6 is greater than 2, but 5 is greater than 1. So strategy A1 is not dominating A3. We can also compare A1, A2, and A3. 1 is less than 6, 6 is greater than 1, and 2 here is greater than 1. So there is no dominance between A2 and A3 as well. But of course, we have seen that A1 is dominating A2 because 2 is greater than 1, -1, 5 greater than 2, and 7 greater than 4. Then for B1, for player B, which is the minimizing player, then player A B1 has B1, player B has B1, B2, B3. Now player B1, strategy B1, we have 2 and 5. 2 is smaller. 1 -1 and 2, -1 is smaller. 6 and 1, 1 is smaller. So B1 is not dominating B2. Then we check again. Let's compare B1 and B3. This 2 is less than 7, -1 is less than 4, and 6 is less than 9. So we can see that by strategy B1 is dominating B3. Let's compare B2 and B3. 5 is less than 7, 2 is less than 4, and of course 1 is less than 9. So in all, strategy B3 is dominated. So we can begin now to eliminate the ones that are dominated. So A1 in A1 and A2, this and this, A1 is going, this and this, A1 is going, B, this and this, 7 is also higher. So A2 will be eliminated. So A1 is seen to be superior to A1, so it can leave. Now let's compare again. Of course, we have seen that in A1 and A2, 2 is less than 6 and 5 is higher than 1. So A1 and A3, no dominance. So let's compare for B again. B1 and B2, 2 is less than 5, 1 is less than 2, but 6 and 1 is less than 6. So no dominance between B1 and B2. So comparing B1 and B3, we have 2 is less than 7, and of course 6 is less than 9. So B3 is also going because it's lesser in value, so it's dominated. So we'll compare again. A1, 2 and 6, 2 is higher, 5 and 1, 5 is higher, no dominance. So for player B, B1 and B2, 2 is smaller, and A3 B1 and B2 here, 1 is also smaller than 6. So there is no dominance again. So we've been able to use this dominance rule to reduce the size of the matrix to 2 by 2 game. So we are going to present the surviving strategies here. So for player A, B, which is the company B here, the company B here, we have the surviving strategies are B1 and B2. Then for company A, surviving strategies are A1 and A3. A1 and A3. And the payoffs are 2, 5, 2, 5, and 6 and 1. 6 and 1. So these are now using the rule of dominance. We've been able to reduce the matrix to 2 by 2 game. So in trying to mix the strategies and find the best course of action for company A and of course company B, where we have so many approaches, we have different methods. We have the analytical method, we have the graphical method, we also have the simplex method. So in this video we're going to demonstrate how to use the analytical method to provide a solution to this. Now recall that what the value that will accrue, that it will yield, the program will yield for A using the max-min and the minimax approach. For player A we have 2, for player B we have 5. So this course of action is aimed at improving on these two, that is for A, that is the value of game for A, and reduce it by improving on it from these two to something else, and reducing this value of game for B2, player B, which is 5. So expectedly, the course of action here, the mixing here, for this, so to say, will provide something in between 2 and 5. But it will reduce from, for player B, it will bring it down from 5 to something lower, and for player A, is going to increase on it from 2 to something higher. So how do we do that? We do that using the probability attachment. So we're going to use the probability estimate to find course of action for them. So what we are saying is, what it is simply, if player A plays A by P, let player B, let it play A3 by 1 minus P. Then if player B, which is company B here, plays B1 by the probability of Q, let it play B2 by probability of 1 minus Q. So it's just about using probability estimate to connect, to find middle points for the two strategies. So using the analytical method, let me clean this. Do not forget that for player A, the value of game using the minimax and max-min approach, for player A we have 2, and for player B, that means minimizing player, we have 5. So let me put it here. For A we have 2, for B we have 5. So using the analytical method now, we are, if player B plays B1, strategy B1, what player A should do to protect himself is to use this probability to select the strategies available to him. So 1, if player A, that is company A, player B plays B1, let player A employ let player B employ 2 by P plus 6 by 1 over P, 1 minus P, plus 6 by 1 minus P. If player B plays B1, player B decides to play B1, let player B kind of counter the action by selecting the strategies under it. So we have strategy A1 by B, and strategy A2, A3 by 1 minus P. Of course, probability sums up to 0. So we're going to bring this down and have 2P plus 6, 1 minus 2P plus 6 minus 6P, which is equal to minus 4P. Okay, let me expand it. 2P minus 6P plus 6. So this will give us minus 4P plus 6, or 6 minus 4P. Then again, if player B decides to play B2, the player A will select player the A1 and A3 by the attached probability. So if player B plays B2, if player B plays B2, let player A employ or play as follows. If player B plays B2, let player A employ 5 by P plus 1 by 1 minus P. Sorry, this player B plays B1. Okay, this is correct. Now, when I expand this, we'll have 5P plus 1 minus P, and this will come down to 5P minus P plus 1, which is equal to 4P plus 1. Alright, so having done this, so the expected gain to A will be computed by equating the two values to get the value of P first, and with the value of P, we now impute it in substitute it in the equations to get the expected value of expected gain for player A. So to get the value of P, we have that, therefore 6 minus 4P is equal to 4P plus 1. This gives me, if this crosses, we have 6 minus 1 is equal to 4P plus 4P. That is 4P crosses and 1 crosses. So we have 5 is equal to 8P, which is that our P will be equal to this by 8, this by 8. So P will be equal to 5 over 8. So the expected gain for player A will be to impute this into the equations. So now expected gain for player A, which is company A, will be, to impute it into this, which is 6 minus 4p, 6 minus 4p, which will give me, or 4p plus 1, 4p plus 1. So I have 6 minus 4 by 5 over 8, or 4 by 5 over 8 plus 1. So both of them should give you the same thing. So I have, this is now 6 minus 1, 6 over 1 minus 20 over 8. And this will now, 4 times 5 is 20 over 8 plus 1 over 1. So we can find the LCM. This is 8. Then 1 by 8 will give us 8. 8 times 6 will give us 48. 8 by itself 1. Then I'll give you 1 by 20 will give you 2. So we have 48 minus 20 over 8, which gives me 28 over 8, and it comes down to 3.5. And the same thing here is take LCM, have 8. 20 plus 8 will give us 28 over 8, which is also 3.5. So we have succeeded in have this to be 5 over 8, now have a 3 over 8, and the value of the game has improved from 2 for A to 3.5. For A, we have improved the value of game for A from 2 to 3.5. So we're going to do same thing for B to see what it will, the effect it will produce on the cost of action for player B. So we're going to clean this off. All right, so for player B, if player A plays A1, B should select his strategies by probability of Q and that of 1 minus Q. So if player A or company A plays A1, strategy A1, player B should play false. That is player B1 and B2 by 2 by Q plus 5 by 1 minus Q. And this comes down to 2Q plus 5 minus 5Q, which is equal to 2Q minus 5Q, collecting like terms, plus 5. So we have 2Q, sorry, 3Q now, minus 3Q plus 5, or 5 minus 3Q. Then for the second one, if player A plays A3, if player A plays A3, then player B should play. So we have 6 by Q, 6Q plus 1 by 1 minus Q. And this expanded, we have 6Q plus 1 minus Q. I have 6Q plus 6Q minus Q plus 1. And this will give me 5Q plus 1. Alright. Now, the next thing will be to find the value of Q by equating the two, because the expected gain of A should be equal. So to get the value of Q, we equate the two equations to be 5 minus 3Q will be equal to 5Q plus 1. So this gives me okay, we have 5 minus 1 will be equal to 5Q plus 3Q. So have that 4 will be equal to 8Q. So this 8 goes here, 8 goes here. So have that Q will be equal to 4 over 8, which is equal to 1 over 2. So my Q here is 0.5 and 1 minus 0.5. So for the expected loss for B, for player B, will now be to substitute the values into the equation. So we have 5Q plus 1 and we have 5 minus 3Q. The expected loss for player B, who is the minimizing player, will be 5 minus 3Q or 5Q plus 1. 5Q plus 1. So we substitute now 5 minus 3 by 1 over 2 or 5 by 1 over 2 plus 1. So we have 5 minus 3 over 2. This is over 1. So we have this is 1.5. 5 minus 1.5 is 3 over 5. Of course, this is 5 over 2 is 2.5 plus 1. Okay, fine. Let's finish it. We have 2. 1 by 2 is 2. 2 times 5, 10. Minus. So 2 by itself is 1. 1 times 3 is 3. So we have 7 over 2, which is equal to 3.5. Now, same thing here, we have this will be equal to 2.5 plus 1, which will give me 3.5. So this is the expected loss for B. So we've been able to bring this down to, this one is now, okay, 3.5. So using the analytical method, We've been able to improve on the gain for 2 when we use the minimax and the maximin approach from 2 to 3.5, and the expected loss for player B or company B is now brought down from 5 to 3.5, giving them the optimal strategy. So you use this probability estimate to combine the strategies for the 2 in order not to be upset by the competing player. Thank you, and see you in our next video.